Okay, so a reminder, Wednesday is your test on 4B. Okay. So let's talk about factoring. Okay, this is the first thing that we learned. So A times C is -18 and B is -7. So what two numbers can I multiply together to get me -18, but add together to get me -7? Multiply to get you -18, add to get you -7. Nobody? God bless. Okay, so that's gonna be -9 and 2. So this will be x minus 9 and x plus 2. Now, you got to pay attention to what the verb is, whether they want you to factor or whether they want you to solve. Those are two different things, okay? Everybody okay on that? Okay, on number 2, it's something a little different than what we've seen. Do you see how there's no C term down here at the back? Okay, when there's no C term, we're going to take out the greatest common factor. So between 4 and 100, what is the greatest common factor? A factor of 4 that's also a factor of 100. 2 is a factor, but what's the greatest factor? Can we divide by 4? Yeah. Okay, so we're going to take out a 4, and they both have an x, right? We're going to also take out an x. So 4x squared divided by 4x is what? 1x. Negative 100x divided by 4x is what? What's $1 divided by 4 quarters? 25 cents, right? So we got 25. Good. This is the factored form. So when no C term, this is what we do. Yeah. Okay, can you try the next two? But on the next two, you're actually solving. So you're going to set them equal to 0 and then solve a little bit. So on this one, you first need to put it into standard form. So you got to add that 2 to the other side. That's going to give me n squared minus 10n plus 24. Okay, now we're going to try to solve. So what two numbers can I multiply together to give me 24, but add together to get me -10? Multiply to get me 24, add together to get me 10. Mm-hmm. 6 and 4, and they're both negative, right? This is going to give me n minus 4 and n minus 6. Now we're going to take each one of those, set it equal to 0, and solve. Or that's just another fancy way of saying flip the sign. Ta-da! Right, on number 4, it's the same thing as what we did on number 2. There's no C term, so we're going to divide by the greatest common factor, which is going to be 3x. We take 3x squared and divide it by 3x, we're going to get x. When you take -18x and divide it by 3x, it's going to give you -6. And we're going to take each one of these, set it equal to 0, and solve. And when we do that, we're going to get x equals 0 and x equals +6. So on number 5, there's two different ways you could have done this. I'm not a big fan of like large numbers. So like if you multiplied 7 times 14, that gave you 98, and then add together to get you 21. I don't know those numbers. Like I don't know that off the top of my head. You see how 7, 21, and 14 are all divisible by something though? What are they all divisible by? Not 3, 7, right? So if I divide this by 7, this by 7, and that by 7, I get 7 times x squared plus 3x plus 2. Now, those are more manageable numbers, right? A times C is 2, B is 3. What two numbers can multiply to get you those? 1 and 2, right? So this would give me x plus 1 times x plus 2. And that 7's just chilling out front. Now it asks us to solve. So what we're going to do is take each one of these parentheses, set it equal to 0, and solve. So that's going to give me x plus 1 equals 0, x plus 2 equals 0, and both of those will give us x equals -1 and -2. Now, if you would have done it this way, that's fine. This would have given you two numbers that multiply to get you 98, but add together to get you 21. Did y'all come up with anything? Oh, 7 and 14. That'll work. Then you're going to divide both of these by 7, and that would give you x plus 1 and x plus 2. And then you would pull that 7 out to the front anyways. Okay, so you can do those either way. I take out the greatest common factor because it just makes it easier. 6, kind of similar. Okay, we don't have a C term. Okay, so what's going to happen is you're going to take out your greatest common factor. Well, is there a greatest common factor between these two? No, but both of these are perfect squares, right? Okay, so what's the square root of 16? That's 4. What's the square root of 25? That's 5. So we're going to have 4p plus 5 and 4p minus 5. When you have perfect squares, this is what you can do. There's always going to be a positive and a negative version when there's no b term. This is no b term. Now, when we solve, we're going to set both of these equal to 0, and then you can solve. So this will give us a positive and a negative version of 5 over 4. Side note, there's always one of these on your finals. Okay, now best and easiest way to check it is to plug it into Desmos and see where it crosses the x-axis. But if you gotta solve it by hand, this is what it looks like. So, have you ever been apple picking in North Georgia? Anybody ever gone? It's kind of fun for about like 10 minutes, and then after that, it's like, this is labor. This is not even fun anymore. But that's just me. But like fresh apples, it's like different type of taste. There's like this place in LJ that makes like ice cream, and then they make like fried apples or whatever, and you put it together, and it's amazing. Anywho, so today we're going to talk about the relationship between the number of apple trees and conifer trees in an apple orchard using multiple representation. Okay, so a farmer plants apple trees in a square pattern. In order to protect the apple trees against the wind, she plants conifer trees all around the orchard. This is what a conifer tree looks like. This is what an apple tree looks like. Okay. Here you see the diagram of the situation where you can see the pattern of the apple trees and the conifer trees for any number of rows of apple trees. Okay, so the X's represent the conifer, the dots represent the apple tree. Okay. Let's explore. Describe how to determine the number of conifer trees for any number of rows of apple trees. You may use drawings, words, and numbers in your explanation. Then describe how to determine the number of apple trees for any number of rows. You may use drawings, words, and numbers in your explanation. So on your paper, that's what I want you to do. Okay, so you're answering how to determine the number of conifer trees and how to determine the number of apple trees depending on the row number. Okay, you can work with a partner. Okay, but I want you to come up with some type of answer. Okay, we're going to take about 5 minutes on this, and then we're going to talk. You need to come up with an answer. Don't just sit there. Okay. All right. So let's talk about the conifer trees first. So that's the X's. Yeah. What'd you come up with for that one? Anybody come up with anything? What was in the, how many were in the first one? Say it again. It adds 8 every row. Does everybody agree with that? Y'all counted those? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I don't know why I put a plus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. So adding 8 each time. Yeah. Okay. Cool. So coming over here, we said we're going to add 8 each time. All right. So what does that look like with like a formula? So we're adding 8 each time. What does that look like with the formula? Like row 1 is going to have how many? Okay. And then row 2 is going to have how many? Okay. So for every row, we're going to multiply by 8. That's what you're telling me. Because row 3 had 24, right? So 8 times 3 is what? 24. Okay. All right. Let's talk about the apple trees. What pattern did you see with that guy? Go back. What pattern did you see with the apple tree? Start off with 1, then we went to 4, then we went to 9. Yep. And then 16. What are those numbers? The numbers I just said, 1, 4, 9, 16. What do we call those? Okay, so what do you know that we're dealing with here? What kind of function? What we've been talking about? Quadratics. Okay, so we know that we're taking the row number and we're squaring it. Okay, so we're taking the row number and we're squaring it for this guy. So take your row number and square it. Okay. All right, so looking at this is what we came up with. R is the input or number of rows. 8 is the constant rate of change for the conifer trees. So with the conifer trees, we're dealing with what type of function? What do we call that guy? It's not a quadratic. Linear. Yep. So it's a straight line. So it's called a linear function. Okay. The exponent of 2 means we're going to have that quadratic. Okay. Right. When are we going to have the apple trees equal the number of conifer trees? Well, if you took r squared and you set it equal to 8r, you could solve that out. Okay. When the row number is greater than 8, that means that the number of apple trees are going to exceed the number of conifer trees. Okay, so looking at this little like graph, we see that we have more conifer trees than we do apple trees. Until right here, now we're going to have more apple trees. Okay. All right, go ahead and go to part 3. Go ahead and answer those questions. Okay, go ahead and go to part 3 and answer those questions. Okay, on number 8. Okay, what you're going to do is you're completing the square. You're going to take your b term, divide it by 2, and then square it. So negative 10 divided by 2 squared. That should be 25. Okay. On the next one, same thing. 4 divided by 2 squared. That's going to give me 4. Okay. Those should be easy ones. Yeah. Those should be easy. All right. On 9, it actually says solve by completing the square. Okay. So we already moved the c term to the other side. We're going to take our b, divide it by 2, and then square it and add it to both sides. So negative 8 divided by 2 and square it. That's going to be 16. Okay, so we're going to add 16 to both sides. So we get x squared minus 8x plus 16 equals 48 plus 16. When we factor this, we're going to get x minus 4 squared. 48 plus 16. What is that going to give me? Okay, 64. Okay. Now we're going to solve. When we take the square root of both sides, that gets me x minus 4 equals positive and negative 8. When we move that 4 to the other side, that means we're going to get x equals 4 plus or minus 8. 4 plus 8 is going to give us 12. 4 minus 8 is going to give us negative 4. So we get 12 and negative 4. I'm seeing a lot of writing, so I want you to try 9b. Remember, move your c term to the other side and then continue the process. So take a second. So I got 7 and negative 9. Is that what you got? 7 and negative 9. Yeah? Any questions on that one? No. Cool. Good job. Okay. All right, on 10, this is the new stuff, that quadratic formula. The way you're going to see this on your test, bless you. It's going to be like, organize this. That's about it. Like, put it in order from, like, the first thing to the next, the last step. Okay. So when we plug this in, remember, A would be 2, B would be 11, and C would be 5. When we substitute it into the formula, we're going to get negative 11 plus or minus square root of 11 squared minus 4 times 2 times 10. I'm sorry, times 5. Where that 10 came from. Okay, all over 2 times 8. So go ahead and take a moment, simplify this, and then we're going to talk about it. Okay, so I got negative 1/2 and negative 5. So what you got? Okay, a lot of people make a mistake underneath the radical. Okay, got to be careful with the subtraction, the negative, etc. Okay. On B, this is where people goof up on their mastery check. When you move this to the other side, this is your B term. Okay. So that's going to give me negative 3x squared minus 4x plus 3 equals 0. Some people moved it over and then they were like, that's the C term. No, wrong. Okay. When you plug that in, you're going to get negative 4 plus or minus square root negative 4 squared minus 4 times negative 3 times 3 all over 2 times negative 30. Take a moment, plug that in, and see what you can get. Okay, so I got this. I got negative 2 plus or minus the square root of 13 divided by 3. Most of you probably got it right about here. You've got to make sure that you simplify the square root of 52. You get this. Everything is divisible by 2 on the outside. And that's how I got this as my final answer. Okay.